Hello everyone, welcome to our pre-calculus class. This is lesson 4. So in this lesson we will try to discuss about the domain and range of the trigonometric functions and fundamental identities of trigonometric functions. So let's begin. These are our agenda. Sign of trigonometric functions in a given quadrant. Although this topic actually we slightly discussed in one of our lesson, but this is still relevant here. We will go through that. Then determine the sign of trigonometric function. So from this topic we have this practice maths. Determine the domain and range of the trigonometric functions, which is a big topic here. Then fundamental identities, very useful for solving the maths. From the fundamental identities we will have to solve some maths. So that's our target. Then the homework as usual. So these are the sign of sin theta, cos theta, tan theta, cosec theta, etc., in different quadrant. So in the first quadrant, this is quadrant 1, first quadrant all positive. In the second quadrant, our sin theta and cosec theta is positive, or just only we can say sin theta positive. If sin theta is positive in any quadrant, since cosec theta is the reciprocal of sin theta, so cosec theta will automatically be positive in that quadrant. And in the third quadrant, tan theta is positive. So you can see tan theta is greater than 0, that means tan theta is positive. Since tan theta is positive, our cot theta will also be positive because they are reciprocal of each other. Then cos theta and sec theta is positive in the last quadrant. And the reason is, if you think about some unit circle, as we said, unit circle, and you can actually think about, let's draw a triangle circle nicely. So if we think about unit circle, then on the unit circle we can think about, okay, what can be the value of different points on the unit circle. Okay, from that perspective actually all of them works. Say for example in this point, some point here, what will be the coordinate of this point, what will be the sign of the value that we will have here. uh, what will be the sign? There will be some ordered pair here, right? Some coordinate here, let's say 2 comma 5, 1 comma 3, or something, whatever it is. So let's say this value is our x value and this is our y value of this point. So x value will be, let's say, m comma n. Let's say m is x value, suppose n is y value, and you will notice that this is m. We are supposing that this side is m, this side is n. So the n, this value will be negative because since this is the origin and this is the negative side, so the n is negative. Okay, so m will be positive, n will be negative. We are just saying m and n, some number will be here. Some number will be here. And you notice that in this value, our first value is actually positive, and our first value is actually cos theta. On the unit circle, first one is cos theta, second one is sin theta. So you can see cos theta is positive in this quadrant. In the fourth quadrant, cos theta is positive. And of course, sin theta is negative. If sin theta is negative, then cosec theta is also negative. If sin theta is negative, then tan theta and cot theta will also be negative because tan theta equals to sin divided by cos. So if sin is negative, then basically the whole thing becomes negative, whereas the cos theta is positive. That's why. So cos theta is positive in this quadrant, and that is the reason why tan theta is positive in this quadrant, because both sin and cos both is negative here, which means that tan theta will be positive here. And to keep it in mind, there are a lot of different mnemonics here. So one is, suppose this is all, for S you can say all should take C. So for C you can say anything, suppose candy, all should take candy, all should take candy, you can say this way. Or you can say all should take chemistry. Why everyone has to take chemistry, I don't know. Or candy is also, that's also not good if you take a lot of candy for your health. Anyway, but everyone loves candy, so let's say it. All should take candy, all should take candy. You must have this in your memory, because then it is really, because you will be using it very frequently. That's the reason. And these are useful. for different maths as well. So see, first one is some application of that concept is here. Suppose if we try to solve some maths, let's say 28 numbers, sin theta is less than 0, cos theta is greater than 0. So where is it? In which quadrant we have that? Sin theta is, that means sin theta is negative, cos theta is positive. So where is it? So you see that is only in this quadrant, in the quadrant number 4. Sin theta is negative, cos theta is positive here in this quadrant. Suppose 32 number, cos theta is negative, tan theta is positive. So we know that tan theta is positive in our this quadrant, which is quadrant number 3. Tan theta is positive. And in this quadrant, actually, cos theta is negative. Less than 0 means negative, greater than 0 means positive. Okay. And suppose if you want to solve this one, this is cosec theta is greater than 0, that means cosec theta is positive and cos theta is negative. Where is it? Where is it? So cosec theta and sin theta, they are same thing in terms of sign. In terms of sign, because they will have the same sign. So we can say that where sin theta is positive, cos theta is negative, and you will see that that is in this quadrant. Now you can say, sir, sin theta is positive. Sin theta is positive not only in this quadrant, sin theta is positive here also. Yeah, that is true. That is true. But you see, the next condition said cos theta has to be negative also. So in this quadrant, everything is positive. So there is nothing negative in this quadrant. So for this reason, we can eliminate this quadrant for this question. We have to look at cos theta is negative where. And you can say cos theta is negative in this quadrant also. Then why not that one? Because we have to look for where both of the conditions satisfies. So both of the conditions satisfies in this quadrant, and similar concept for these two maths as well, and all of the maths, of course, eventually. We have to look for where both of the condition satisfies. Okay, we have to look for that. That's why we get the answer this way. So you can try solving the other maths and check that. This is actually directly taken from our 6.3. This is 6.3 in our book. Okay, in the PDF book, section 6.3. Then we have determining the domain and range of trigonometric functions, trigonometric identities. So what is the, how can we find out the domain and range? This is very important thing, and in terms of concept development, domain and range is always very important thing. Domain, what is domain? Domain means the possible input for our given function, or valid input of given function. That is the domain. And range is the output of that function, is the range. So you see what will be the domain from this circle. If you look sin theta, first one, what can be the domain of this function, or what are the theta value we can put here? What are the valid theta value we can put here? What are the value of theta that we can put here? That is actually our domain. Then range means what are the output, answer. If sin theta goes to suppose 30 degree, what is the answer? Cos theta goes to 45 degree, what is the answer? Answer is the range. Domain is the input. Domain is the input. Now if you look at this figure, you can see actually the value of theta can be anything. We can put anything here in the sin theta, sin whatever we want, sin 10 degree, 20 degree, 30 degree, 40 degree, 90 degree, sin suppose 120 degree or 180 degree or 270 degree, or any value here, whatever you want, you can just put here, and you will see calculator will start giving you answer for everything. Whatever you say, calculator will start giving the answers. So we will keep getting the answers for whatever we want. We will keep getting the answer. And we can see it from here also. This x and y, these things also tells us the similar thing. And now you look at the cos theta. Cos theta also actually does a similar thing. Because any value of cos is defined everywhere we want. We can actually put that. Anything that we want, we can actually put in the cos theta also. But when it comes tan theta and all other values, tan theta, cosec theta, sec theta, and cot theta, we can see there is a problem here, there is something like divided by x here, divided by y here, divided by x here, and divided by y here. So we know that if something is, suppose y divided by x, this x value cannot be 0. This x value cannot be 0. That value, for that value our function is not defined. So we can look at in this given unit circle where our x values is 0. Our x values is 0 here. You can see the x values is 0 in this case, and in this case our x values are 0. That means our tan function and sec function, let me erase this and uh, let me erase this and circle this only 10. So this first one, and this is 10 divided by x, and this one is also divided by x. These two function, these two, this is divided by x, so x value cannot be 0. X value is 0 here, x value is 0 here, this is the x value, this is also the x value. So 0 here at 90 degree and 270 degree. That means 10 90 degree value and then 10 270 degree value, there will be no value for that. And you can check it in your calculator also. Suppose 10 90 degree equals to what? Calculator will say that this is math error. So I just pressed it 10 90 degree, or you can say see 2 10, this is 10, then if I write 10 90, what is happening? So yeah, I think for some reason video is switched off. I think it's coming back. Okay, so that you can see I am actually using the Zoom, our usual class system for the recording, so that I can actually draw all the things and some thing I also can show at the same time, and we can use all the tools. That's why this Zoom thing we are using. So I don't know, for some reason it is taking time. So let's continue the discussion. The point is tan theta is not defined at 90 degree to 70 degree. Similarly, sec theta also is not defined at 90 degree and 70 degree. Not only 90 degree and 70 degree, basically if we come back, if for every bigger value of that actually is not defined in that angle. What I mean by this is, suppose you know that by now you know that 10 90 degree value is undefined and 10 to 70 degrees value is also undefined. But you see, if we go here and then if we come here, this is 360. So 360 plus 90, 360 plus 90 equals to 450. That means 10 450 is also not defined. Yeah. So if we go come back again and again and again, every time we hit this bar for the tan and for the sec, this will be undefined. And same thing goes with this line. Every time we hit this exact line, our tan will be undefined. Sec will be also undefined. Hit this bar, which means that we come here to 70 degree. Then we come here and come back, and again we come back here. Then again it will be undefined. So which will be 360 plus 270, 270. That means at 630 degree, this will be actually undefined here. That will be again undefined. So this way we can understand actually when this function will be undefined. And similar thing goes with the cosec and cot, but only difference is in this case y cannot be negative. Y cannot be 0. Y cannot be 0. Okay, so it says that maybe I have some fluctuating internet connection. I can use mobile data also for that if it's needed. Okay, I'll do that. Okay, let me try to connect the mobile data, because so that I can graph it. Let me connect mobile data. Yeah, so that's my mobile. Now how do I know that? Sorry about this. Let me take just a while. So let me go there and try to start the meeting again. It will take 30 seconds, not more than that. So my account, where is it? Meeting, personal meeting, start. I think by now it should be fine. So let's go back to our slide. I was discussing this page, so come here. Yeah. So now everything is good. So I can go there, come here, share screen. So yeah, let's come back. Anyway, so things are good now. Again, for y, now we can again draw and do the things that we used to do. Again, for y, we have to look at where y is 0. This is this because the function is defined that way. Y is 0 here and here. So for these two value, for 0 degree and for 180 degree, actually our this function, this cosec and cot theta is undefined. So we will not get any value here. We will not get value here. And we can actually now see where everything is going. Let's look at the graph of sine theta, cos theta, and tan theta just to understand what it does. Okay. And for sine theta, cos theta, tan theta, this kind of graphs, actually we have classes for this kind of graphs, and which will be later sometime. We'll just now to show you what the graph will look like. This is an example. This is some just to show, but this all the graph we will try to draw when our this sine function, cosine function, and tan function will come. But to give you one, give you some idea, this is the graph of sine theta. Sine 0 degree equals to 0, then we can go sine 90 degree equals to 1, then it comes here, and if you draw, you will see that, you will notice that the function actually works like this. This is called actually sinusoidal graph also. And you notice that the value of sine, the maximum value of sine is here. Let me point it out. You will not have to draw it now, just look at the graph. This is 1 and this is -1, and you will notice that the output, this is the output and this is the input. This is actually the domain, and this is actually the range. The second value is actually the range, the first value is the domain. So if you just want to look at this, the first value, this is pi by 2, that means 90 degree, then pi, then 2 pi, then you see the graph continues. In the negative direction also, graph actually continues forever, which means that you can put any value you want, like 90 degree, 20 degree, 200 degree, whatever comes to your mind, but the graph will just flow between these 2 points, plus 1 and between these two value, plus 1 and -1. The entire graph, the value will value of the graph will be between these two, which means that the domain is all real number for this function, and range is +1 to -1. Okay, and this one also you can see the value, 0 degree value cos, this is the cos function. This is the cos function, color, yeah, I think. So sine 0 degree equals to 0, 0, 0, sine 90 degree equals to 1, so sine 90 degree equals to 1. Okay, this is the cos function. So for cos function graph is also similar. Cos function graph is also similar, +1 to -1 it goes, and you can put any value. This way also we can view it. Okay, I was wondering about the color coding. I think this color and this color should match anyway, which is not that big deal though, but it should match usually. Y equals to tan theta, so tan theta graph is this one. You will notice that for some particular points, tan value actually goes forever after some particular points, then it decreases also forever. It goes forever up and it comes forever down. Because of that 90 degree, at 90 degree tan is not defined, that's why all of a sudden graph starts going up. It do not cross the 90 degree, then again it starts, because after 90 degree, if you start from 91 degree, 92 degree, then the graph again starts giving some value, and then the graph starts giving some value. So this is how what happens for this sine theta, cos theta, and tan theta in terms of their graph. These graphs, how it helps to just visualize the domain and range. These graphs actually helps us this way. And we actually summarized all these things what we said. For sine theta, it takes all the domain, and the range are between -1 and +1 inclusive. Inclusive means +1 and -1 will also come. That is the that is the uh, that is the range. For cosine, similar, sine and cosine is similar. For tangent, you see tangent for tan theta actually, for 90 degree and then 270 degree, that means our odd integer multiple of pi by 2, 90 degree. What does it mean? Let me show you that a bit. So this is 90 degree, and another value what we said. So 90 degree, we said that, see this value 90 degree. Here our tan theta is not defined. Here also our tan theta is not defined. So first one is 90 degree, second one is 270 degree. So 90 degree means pi by 2. And then 2 pi by 2 you can say, but that is not. 2 pi by 2 means pi actually. Then 3 pi by 2 means 270 degree. Then next one will be 5 pi by 2, where the graph is not defined. Next one will be 5 pi by 2 for tan theta. Then next one will be 7 pi by 2. That means odd integer multiple of pi by 2. At all the odd integer multiple of pi by 2, this tan function is not defined. And of course, same thing goes with the other thing. See the sec theta, except odd integer multiple of pi by 2. Because of this 0 and this 0 here. And the other things is here. See 180 degree, 180 degree. For 180 degree, 180 degree, of course at 0 degree also they are not defined. Okay. And for tangent function, all real number tells us that whatever you put, your output will start coming all the values, regardless of any restriction. There is no restriction for that. So tan function will give us output many other values. All the real number will keep giving us. All real number greater than or equal to or less than. So here, this function cosecant function, which means cosec, we can just simply say cosec. It means that the range of this cosec function, this line and this line is actually same. Then this line and this line is same. So all real number greater than or equal to 1, which means that from 1 to plus infinity side, then inclusive, and then less than or equal to -1, that means from -1, minus infinity to -1, all the value. So why is this so? Why is that? Suppose cosec function, why the output is like this? Why the output, why the range is like that? The reason is this cosec function is actually 1 divided by sine function. 1 divided by sine function. And same goes with secant. Secant means 1 by cos. So you see, suppose sine, let's say sine something, sine 45 degree. So what is the value of sine 45 degree? Sine 45 degree means root 2 by 2. Root 2 divided by 2. Then sine 45 degree value. Or let's say sine 30 degree value equals to what? Or let's say sine, whatever comes. Sine, let me write it here, sine 1 divided by sine 30 degree. Sine 30 degree value means 0.5. So 1 by 0.5 means what? So 1 by 0.5 means 2. 1 divided by 0.5. So answer is 2. You see, answer already started getting bigger than 1. Or root 2 divided by 2. So if we write root 2 divided by 2, we get 0.707. Then 1 divided by answer, it gives us 1.41. So it tells us the value is becoming more than 1. This is what I want to say in this point. And I can show you this thing in a more easier way. Suppose this cosec means 1 divided by sine. So this the angle's value will be here, right here. So sine theta value can be like 0.1, 0.2, 0.3 also, or 0. Suppose 0. Let's say 0.1. If it is 0.1, then cosec theta for some particular angles, for some angle, then cosec theta will be 10. Do you understand? In that case, cosec theta value is output is coming 10 for that particular angle. because to eliminate this decimal, we can write here, we can give here a 0. Then if some value is like the 0 point, suppose 0 0 0 0, let's say 0 0 1, it can happen, it can happen for different angles. Because why? The reason is the value of sine theta is the range of sine theta is from -1 to 1. So this value is actually between -1 to 1. This value is actually between -1 to 1. 0.001 is between -1 to 1. So my point is actually it can have this value. So say this has these values, then what is the value of cosec? So 1 divided by this means actually 1 0 0 0. So basically we get this thing here. That means our range is becoming 10, 1000, 2000, or bigger and bigger value. And same thing will happen in the negative side as well. And the first value, it will start at 1. Why it will start at 1? Because this is 1 coming from the formula, because sine theta means 1, cosec theta means 1 by sine theta. So 1 divided by sine theta. So sine theta's maximum value can be 1. So sine theta's maximum value can be 1. So if we write 1 by 1, then we get 1. That means this is the value of cosec theta now, because we have put the sine theta's maximum value here. That's why it starts from 1. Then other values are less than 1. Smaller than 1. So if downside, this down number is smaller than 1, then 1 divided by smaller than 1, this number actually will start becoming bigger, between 0 and 1. If some number is between 0 and 1, then it will start becoming bigger, because 1 divided by 0.2, 1 divided by 0.3, 1 divided by 0.002, they are actually more than 1. These values are more than 1. And same will happen for the negative value also, for the negative side also, because between 0 to -1, we have tons and tons of values in between. Even between 1 and -1, we have actually infinite number of numbers. Many numbers we have, small numbers. So all these things are why I'm saying all these things is just those who want to understand all these things, you can actually try to think this way, because then it will start making sense, like why it is this, why it is that. These are the logical basis of the thing. Okay, but generally you can just try to go through this chart. It should actually give us uh, most of the answers of the question, direct answer of the question, but of course there are always explanations for that. This domain and range will help you to understand the trigonometric problems better. Okay, this domain and the concept will always help. And main thing for understanding domain and range is this unit circle, by the way. Always keep that in mind, that unit circle actually helps very much for discussing all these things. And yeah, so this one is fundamental identities. We have sine theta, cos theta, tan theta, sec theta, cosec theta, and cot theta. These six, they are the six trigonometric functions, trigonometric identities, expressions. Then we can actually establish some relationship in between them. And first of all, if I ask like why there is 6, sine, then cosine or cosec, sec, cosec, after cosec, let's write cos, then sec, then tan, cot. Why there is, this is sine. Why there is 6? Why not more? Why not 5? Why not 7? Why sine, cos, sine, cosec, cos, sec, tan, and cot? Why there is 6? The reason actually is here. If you draw some triangle, here, let's take a straight line from here. If we draw a triangle here and then another triangle here, this is a triangle, and some angle we can give here, and you will see this sine, cosec, cos, sec, tan, and cot, they are actually the ratios of these sides. So there are 3 sides here. 1 2 3, or you can say 1 2 3. And if you take, suppose this one, if you take the ratios of this one number, then you can take this one and this one and this one and this one. So two in two way you can take the ratio. Then again for this one, if you take the ratio for this one, you can take, suppose this is the uh, if we give the angle theta here, then this is our opposite side, opposite by hypotenuse, opposite by base. You can just give it this way. And for this one also you can do in two ways. So total in 6 ways you can rearrange this thing. That's why only 6 thing is enough and sufficient for the for explaining the ratios, eh, for explaining the ratios of the sides, or some yeah, ratios of the sides. Everywhere there will be theta, by the way, because without the angle they are meaningless. And we defined these things are the fundamental definition, sine theta, and we need the cosine theta. Cosine theta actually then comes to cosec theta. Similarly, cos theta and sec theta, they are the reciprocal. These are the reciprocal of each other. And this cot theta and tan theta, they are the reciprocal of each other. Suppose this one, say opposite by hypotenuse, let's give it a name. Then hypotenuse by opposite, let's give another name to this. This way all these things started coming. This is sine square plus cos square theta, and from this formula this one and this one comes. This formula comes from where? And this tan theta equals to sine theta by cos theta, because this is how we actually achieve our tan theta, because tan theta is actually the ratio of this is the tan theta, means the this is this one. Tan theta is the hypotenuse. Hypotenuse is the gradient or slope of this triangle, and slope means rise over run. So this one is cos theta, this one is sine theta. So this is how we get the slope, rise over run. This one is, let's put it this way. So slope is rise over run. So run is cos theta, and this is sine theta. And in this case, this is actually, if we give the angle theta here, then this becomes cos theta here, and this becomes sine theta here. And our slope is negative in this case for this triangle. So sine theta by cos theta, for the positive slope, we can define it this way. And this sine square theta plus cos square theta also, as you know, this sine square theta plus cos square theta, from here we establish this relationship. If it is unit circle, then always if we square this one and this one, our answer will be -1, since this is the unit circle. And tan theta comes, this two formula comes from here, because if we divide this line by, this is sine square theta, so let's divide the whole line by sine square theta, then we will get this formula. And if we divide the whole line by cos square theta, then we will get this line. You can see cos square theta divided by cos square theta. So 1 by cos square theta means sec square theta. So from this one we can derive them. Now where it helps, it actually helps us in many ways, because if we want to convert in between them, then actually they helps us. Suppose sin theta value is given, now find out the cosec theta value. This way we can actually find out the other things when we use them in different perspective. And we have that kind of example here as you can see. Say sin theta and cos theta value is given, we have to find out the other 4. So find out the exact values of the four remaining. This is the last page. We have to find out the 4 remaining trigonometric functions. So 2 is given here. Suppose this one, this math, any math if you want me to solve, they are actually same. So sin theta is 4 by 5. What are the remaining things? Sin theta and cos theta given. So sin theta is, so cosec theta will be what? First of all, this is easy. Cosec theta is the reciprocal of sin theta, which means that if it is 4 by 5, cosec theta will be 5 by 4. We are using the fundamental identities of trigonometric functions, trigonometric expression. These all are actually so far all of them are written in terms of expressions and equations. We can say these are equations. So cos theta equals to this, then we can write here, from here we can write sec theta. Sec theta equals to minus 5 by 3. Then tan theta will be what? So tan theta is, we can divide sin theta by cos theta, so it will be 4 divided by 5 divided by minus 3 divided by 5. So we can just write it 4 divided by 5 into this 5 will go up, 3 is down, so 5, then minus 3 here, 5 cancel out, so our answer is 4 divided by 3, or minus is here, we can write this minus here just before the number. So this is the tan theta, and once we have tan theta, we can find out the cot theta very easily. Cot theta we can find out now in two ways. One is we can do cos theta divided by sin theta, this way we can find out, or we can just simply take the reciprocal of this value, which will be also our cot theta. So once we start using this fundamental identities, we can actually find out the other things easily. And by using, there are other mechanisms also for finding different values, which we will discuss in our next class, because we have more classes from these sections. So in the meantime, you will try to solve 29, 30, 33, and 34, and then some other maths from here. These are the optional questions. These questions we will discuss in the next class, this topic. But if anyone can solve, you are welcome to give a try. So that's all for today. Thank you all. Thank you very much. Have a good day, and see you all in the class. Bye bye.